Hello everyone. I have a bit of a cracked voice, but it won't be that. Yes. Yeah, but at least I'll be in the frame. So what I want to talk a bit shortly today is the Ethereum Pectra upgrade. It's a fresh topic. It's due to be live in the next month. They've promised. We know that Ethereum people tend to follow on their scheduling promises quite well. So let's hope for the best this time. The way we will approach it is that we'll do a quick refresher in case of somebody here not knowing how today network upgrades in the Ethereum ecosystem operate. Then we'll focus on the updates to the EVM, updates to the consensus, and when it's all due. It was very late yesterday evening when I was preparing this presentation. I had a killer joke to make, but right now I have just the slides and I've completely forgotten the joke. So it goes something like this. The future might look bleak, but don't worry, we are quite possibly living in the worst possible timeline, and it can only get more entertaining from here. So let's talk briefly about the past. Ethereum started out 2015, Frontier, fork, it enabled the Genesis block, the block started producing, then we got Homestead, we got the first replay protection, Tangerine Whistle, EVM upgrades, DOS protections, DAO hacks happened somewhere here. We determined it's best to just rewrite the history of what happened and give the foundation back its funds. Then we got Byzantium, Constantinople. The network kept upgrading in a pretty linear manner. But what happened sometime, I think around 2018 or 19, a completely different network started operating, which we today call the beacon chain. It was completely separate from the Ethereum network, but it kept getting its upgrades on its own. The Ethereum, as we know it, continued upgrading. We got the Berlin fork, the London fork, with better gas incentives and monetary policy of the network. And the first upgrades to this completely separate network started happening as well. In the end, with the Paris fork in Ethereum, a specific event took place, which we call the merge, when these two networks started operating together, borrowing the security from the beacon chain, where today we have somewhere near 900,000 validators, operating with the Paris version of the EVM virtual machine. So what happened after that is we got Chapella. Network upgrades started being called as an amalgamation of these two verbs. The best way to, I just figured out while preparing this presentation is that execution layer or the EVM upgrades are always called, borrow their names from cities around the world, and these are all stars. I didn't know, but they're either stars or constellations. So yeah, yesterday I learned. Then we got Denkun, and the thing that we're going to be talking about today is the Pectra upgrade, the Prague version of the EVM, and the Electra version of the beacon chain. So first things first, Electra handles everything when it comes to security, validator attestations, votes, entering the network as a validator, exiting the network as a validator, receiving rewards, whereas Prague just takes care of our transactions being executed correctly. And these two recently have a new thing where a new intertwined dance together, which are the blobs, which are Ethereum's answer to cheaper data availability. So let's first talk about what are the changes to the virtual machine, what are the changes to the execution layer that I think are quite notable. So it's a pretty unimpressive upgrade when it comes to the EVM changes. We've done some quality of life improvements. It's easier now to configure your execution layer nodes and to tell them, hey, this is how much blob space we are aiming for. The blob schedule is written in the EL configuration, no more complex communication between your consensus clients and execution clients. General purpose EL requests also aim to simplify how these two nodes operate. Why I'm talking about this? Because it's important to right now understand the trend of people soon we are talking in the next 3 years, being able to completely separately run these two networks. Statelessness and light clients might help this, but it's pretty clear that with the EIPs that are being scheduled, people are less and less focusing on heavy communication between the CL and the EL locally, of course. We're increasing the cold data cost, something that we can now do without worrying that rollups will start abandoning the ecosystem, simply because we now have blobs. Something around 70 to 80% of all rollups have completely upgraded to using blobs for intermediate storage. We have a more secure BLS curve, so signature aggregations no longer depend on 80-bit key sizes. Right now, with this specific curve, we can go above 120 bits. One more important thing for people who are designing bridges, for people who are designing oracles, which are taking up a lot of gas on the Ethereum L1, we will have a system smart contract which will store a recent history of block hashes. So oracles will no longer need to operate their own source of truth when it comes to block hashes for people to submit witness proofs to, but it will be tackled on the protocol layer itself. But the thing that I think is most important, and it's a bit confusing when I first heard that it was being scheduled for the next upgrade, is the next big thing in account abstraction, which is the EOA account code, or EIP 7702. So that's what I want to talk a bit more about. So in essence, what EOA account codes mean is that you can temporarily or ephemerally set a specific authentication code, set a pointer to a specific authentication code to your externally owned address. That means that your, let's say, MetaMask address, you can instruct it temporarily to authenticate using codes from already deployed smart contracts. You would basically say, hey, when I want to interact with this EOA, use the bytecode that's deployed in these smart contracts. And this can be anything you want. For a complete suite of what's possible, I instruct you to take a look at safe contracts, which have a lot of plugins for authentication, which support WebAuthn, which support all these different curves, which support all of that, but they rely on somebody else bundling the transaction and sending it for you. This being a protocol level change, you would be able to do all of this on your own from a wallet that starts implementing and supporting 7702. Right now, we have Privy who's doing that. Have you heard of Privy Auth? Yeah, some of the people have. They were pretty big and pretty involved with this EIP. But on the other side, we have no clear indication that other wallets, the biggest wallets of them right now on the market, are really following this direction. Hopefully they will. We will talk a bit about how this changed. So the next thing is DEX gas payments. Hey, I'm a new user. Everybody, when they're talking about account abstraction, they're thinking about new users. How do we onboard the next billion people to using Ethereum? Well, it's possible to do this as with any AA scenario. It's possible to swap your Dogecoin for the native currency, pay the gas fees in the native currency, and execute the transaction that you intended. And third, which is for me most exciting, if you were ever swapping anything on, let's say, Uniswap, you know how irritating it it was, how still a bit irritating it is that you have to click on multiple prompts to send first your ERC20 approvals and then to initiate the swap with the contract itself. Well, we can have atomic batched transactions without added infrastructure and smart contract gas fees. Next, this is the part that I presume will be pretty wild, especially with all the agents as the current hype in the wider industry. AI agents as the hype in the wider industry. You will be able to set temporarily authentication mechanisms on your EOA and the completely autonomous, let's say it's another EOA or it's an invoked smart contract, it would be able to execute things on your behalf, meaning that for all for all smart contract developers here, meaning that the origin of the transaction as seen by the origin opcode would still be your EOA. So this is pretty big. A lot of incentivization mechanisms, a lot of careful thinking has been done so far to circumvent that we don't have it built into the protocol, but this is huge for having session keys, for enabling less friction in Web3 gaming, and for doing all sorts of stuff with autonomous handling of your funds that you don't have to click anytime your AI agent wants to do something. I'm not that acquainted with the use cases for AI agents in crypto, so yeah, forgive me. But the topic that somehow begs us to talk a bit more about it is, what, 2 years ago? Can somebody correct me? Year and a half ago, we had ERC 4337 as a pretty gentle introduction of account abstraction to Ethereum. I myself don't see a lot of benefits in the software that I use every day to interact with the chain that 4337 brought me. But its idea, which can be seen by the prefix itself, this one is an EIP, this one is an ERC. What's an ERC that we all know? It's ERC20. But when people first thought of, hey, let's have a standardized, let's have a token standard that all wallets can interop with seamlessly, it was a request for comments, Ethereum request for comments. People didn't need to change the protocol to make it work. People were just discussing about standardizing certain things, such as ERC 721 for NFTs, such as everything else that comes with an ERC in its name. So ERC 4337, the sole fact that it's an ERC, that it doesn't change the protocol of Ethereum, makes it gentle, as I said when I was talking about it. And what makes it gentle is that all the introductions, all the technical solutions for enabling us to bundle transactions, to include sponsored gas transactions on somebody else's behalf, that is all done pretty much off-chain. You have an alternative mempool. That alternative mempool is not a part of the network itself, as we experience that every day with MEV. But this was a pretty gentle solution in a sense where you, to consume the account abstraction offered by 4337, you had to integrate with basically a third-party solutions provider. You had to find somebody who would bundle your transactions for you, who would verify, who would help with the verification of your transactions and submitting them on-chain. So what EIP 7702 does, it goes head-on to implementing account abstraction. It plays well. These two play well. But what I think, why I think that 7702 will have a much bigger impact on the UX is because we're not solely thinking about, hey, how do we bring the next billion users on chain without messing with the protocol? No, we're thinking about how do we do all of these validated things that people are doing with save contracts, for example, where they have complex authentication schemes, complex ACLs, however you want to call them. How do we make them a part of the protocol where we don't have to rely on good people from SAFE in maintaining and auditing their code? We don't have to rely on the bundlers that they provide good bundling relays for the transactions, but we have Ethereum providing for us what we need. And that is custom authentication methods, gas sponsorships, and even, as we saw here, autonomous transaction executions even on EOAs. I'm going to pause here for a bit. Yes, this is the end of the machine part. Does anybody have any questions about it? Yes, please, engineer.
Do you think this new EIP 7702 has the potential to impact certain companies, protocols that are building on 4337? Could it remove some of their use cases?
Yes, definitely. In a similar sense as peer DAS would, in my opinion, and I'm always going for let's have it all in the protocol. If you validated that what you as an infra company in Web3 are offering to the people, your biggest threat is not your competitor, your biggest threat is the smart protocol guys from the core team implementing all of that in the protocol there. So both blobs and this are a huge threat to some shitloads of VC money in this sphere. Yeah. Any other questions about? No? Okay, let's move to the consensus part. So this is the Electra. Electra is a star, as I said, very important to remember. We have blob throughput increase. People thought that we were pretty conservative about the limits that we set for blobs, and it artificially rose the prices, but we see that we can increase the blobs without sacrificing the blob throughput without sacrificing decentralization. Community index outside attestations. This one is related to light clients. Actually, we would be able to, with this, we would be able to more easily create zero-knowledge proofs of Ethereum's consensus operating correctly, which is huge for light clients. And validator deposits on-chain. This is let's say, a quality of life improvement. So not that important. This one is important, but I hope we'll have a chance to talk about it once we have true statelessness. Once we have true ability to instantly to verify the correctness of the blockchain without having to trust anyone or without having to completely execute everything on our own. What I want to focus on and what really got me excited about this talk is these two EIPs. They might sound pretty simple, but they were not simple, and even they took a lot of careful thinking considerations how it will impact the network incentives. Well, the max effective balance incrementation means that you still need 32 ethers to become a validator in the network, but you can stake up to 2048. What this means is that Ethereum, which I must say I love Ethereum because of this, nobody thought, hey, but if we increase the limit to 2048, these people and companies with huge bags of money who are staking their ETH and who have, let's say, 200 validators, that means 200 times 32 ether, locked in a single validator, hardware validator on the chain, but acting as 200 of them, that means that our statistics when it comes to decentralization will appear less. Well, no, they will appear more fair, and we would finally be able to know how much validators there really are in the network. Nobody would have the incentive of further registering new validators for each 32 Ether that they have, simply because of gas costs, simply because of operational costs, and a bit more of hardware resource usage. So if you have somewhere between 32 and 2048 Ethers, you can freely stake that amount and you will be rewarded appropriately. So this is a big thing in my book, and we can expect, because there are migration paths for all of these, there's a, I forgot the name, it's not consolidation, but it's something like that. There's a path for people to apply for joining their multiple validators together and having simpler staking operations on their end. So yeah, we can do that now. And the next thing is, you've all heard of, I don't know, Lido, Figment, companies like that offer non-custodial staking solutions. Well, it's not that, it's not a well-known fact. The gaping hole in security and how much trust even non-custodial staking solutions so far required of all the consumers, of all the users of those solutions. So let's see where the problem was and how it is fixed. So as a refresher, the way staking in Ethereum functions right now, we have two sets of keys. We have a withdrawal key. This is a plain simple regular EOA on the chain where you as a staker, you would sign a certificate saying, hey, I want all of my rewards to be distributed to this address, and this EOA always lies with you on your hardware wallet somewhere. This is the address that's receiving all the rewards that you have, and this is the only address to which the stake can be withdrawn once you exit the network as a validator. The other set of keys are the consensus keys. This is a completely different curve. This is a completely different use where you use these keys to attest that you have, that your subnet committee or whatever hierarchical organization in the consensus has validated a certain block, has validated that the block is correct and can be included in the chain. So these consensus keys, in most cases, are operated solely by the non-custodial staking service, because we've all said, hey, that's completely fine. I know that these people cannot steal my rewards. I know that these people cannot withdraw my stake to their account. The worst that can happen is I stop being a validator and I get my 32 Ether back. Well, that's not exactly the case. You as a staker, as a person who's using the non-custodial staking service, sometimes you would want to unstake and get your 32 Ether back to buy a house. Well, it's the non-custodial, it's the institution that's providing non-custodial staking services to allow you. It's up to them to allow you to do that, because they have to vote using the consensus keys that your withdrawal account gets the stake back, which is a pretty broken game of incentives if you think about it. You're getting the rewards with most of these services, but what you're not getting the entirety of the gas fees when you are the lucky winner for producing a block. The majority of those funds usually get the staking services, and that is the playground where they compete with each other. Who has the less fees when it comes to proposer rewards? In this case, they don't have an incentive to let you unstake. We haven't had huge incidents of big companies preventing people from unstaking, but it's pretty clear why they would potentially think about that. So luckily, where Ethereum is going is that in less than a month from now, we will be able, on the execution layer, meaning on transactions that are popping up on Etherscan, you would be able, with your withdrawal key, to request the validator exit and unstake, meaning that your Whatever you want to do is in your hands, not in the hands of the non-custodial staking operator, which what I expect is that more serious people start entering this kind of things, people that will get themselves informed about how all of this works before getting into it. Of course, this broken incentive system brought us some wonderful tech, such as distributed validator technology, where you always have to keep some hardware online that's much less expensive to operate in order to have the consensus keys sharded with you and your staking service. But right now, again, as engineer pointed out, a lot of these upgrades are slowly making some complex and really cool technical solutions that we needed a couple of months ago obsolete, which is how a network should evolve. Yes, we talked about the triggerable withdrawals, and I'm going to end the talk. Luckily, 6 days ago, there was a core protocol meeting. They're all public on YouTube. There's no Ethereum inner circles that I know of, where they determined it's too much of a risk to include the EVM object format. It would be very hard for Lazar to prepare this presentation if they determined to put it into the fork. So luckily they didn't. They delayed peer DAS, which was a lot less mature anyway, which is the data availability sampling protocol. And the Pectra, as I explained it today, will go live on testnets in a matter of weeks, and hopefully in the beginning of March, we can see it on the mainnet. That's all, and yeah, let's keep Ethereum awesome. Thank you. I forgot to ask, are there any questions about the consensus part of things? Yes, please, Mother.
The withdrawal keys will probably work from now on. So are they compatible with backwards compatibility?
Yes, everything is backwards compatible. In the case of the EL triggerable withdrawals, there is no migration path. It's a drop-in upgrade.
No, but the withdrawal key, how does the network know for the withdrawal keys of the current users who have staked with the non-custodial staking provider?
Because you have a certificate on the consensus layer that says, hey, you cannot change my reward address. Mm-hmm. This is the part. I didn't draw it, but this here are the rewards accessible by withdrawal key. This is a known fact. Mm-hmm. So there is a mapping between the two.
Okay.
Thank you. Any more questions?
Thank you.